In the beginning, there was darkness, and then bang, giving birth to an endless expanding existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. This cosmic world is unlike anything you've ever seen or learned about. Our galactic neighborhood is home to 7 of the most mesmerizing, violent, and otherworldly phenomena in the universe. A stunning planet whose iconic rings contain mountain ranges that rival the Alps. A shimmering moon where massive geysers of water and ice spew from its surface. Scale a mega volcano. Then zigzag through a family of asteroids before diving into the eye of a supersized hurricane. Experience the newest, most mind-blowing discoveries revolving around our sun as we venture in 3D to the 7 wonders of our solar system. If you think science has already uncovered every dangerous, strange, and extraordinary phenomenon under the sun, think again. We are right now in the midst of the greatest era of space discovery. And many of the weird and wondrous things are happening right here in our own cosmic backyard.
Our solar system is a really fantastic place. You know, we've now found other planetary systems, and we've not yet found anything quite like our solar system.
You've joined us on a magical 3D journey through the 7 wonders of our solar system. We first head for the orbit of Saturn. Number 7, Enceladus. It's midnight, November 2nd, 2009. NASA's Cassini spacecraft orbits the planet Saturn. Its cameras capture something bizarre on one of its outer moons, named Enceladus. Most of the solar system's moons are geologically dead. And looking at the glistening icy surface of its south pole, Enceladus seems like a peaceful world. Then suddenly, without warning, gargantuan geysers of water and ice eject from cracks on its surface.
Enceladus is a fantastic moon of Saturn. Though it's relatively small, Enceladus is different from the volcanism that's here on Earth, where hot magma, which is basically molten rock, comes out from underneath Earth's surface. Enceladus has water, basically, liquid water coming out and freezing, and so it's called cryovolcanism.
The Cassini spacecraft flies directly through the energetic plumes that blast hundreds of miles into space at 1,400 miles per hour.
Enceladus has really caught our imagination recently because we see geysers coming out of the South Pole. We haven't seen anything like that on any of the icy moons in the outer solar system. So something is going on in Enceladus, and it's active, and we want to know why.
Scientists have counted at least 30 geyser jets spouting from narrow geological fractures called tiger stripes, located along Enceladus's south polar region. A new 3D infrared map of the area reveals warm surface temperatures. The heat emanating from the tiger stripes may be due to the upwelling of water vapor that propels the jets. One of the few other places to witness this truly fascinating wonder is on Earth. At a freshly groomed ski slope, or on a movie set.
Wow, look at this snowmaking machine. It's like a geyser from Enceladus. All these ice particles and water droplets freeze when they encounter the outside air. And the expanding gases also help cool the droplets and freeze them. In the case of Enceladus, heated liquid water in a cauldron below the surface goes squirting out through some vents in the south polar region. And when that water comes out and encounters the cold surrounding space, it freezes, forming snowflakes and ice particles, much like the ones coming out of this snowmaking machine. So wow, I might as well be on Enceladus right now.
Scientists think there must be two internal heat sources driving this icy volcanism on Enceladus. One source could be radioactive elements that decay and heat up the interior, thereby keeping the water in a liquid state. The second could be tidal heating.
Suppose Enceladus is like this squishy balloon. Now, Enceladus orbits Saturn in a slightly elliptical, eccentric orbit. So sometimes it's closer to Saturn, sometimes it's farther away. When it's close to Saturn, Saturn's gravitational pull creates a greater tidal stretching of Enceladus than when Enceladus is farther away. That leads to a rubbing of the interior materials and a release of energy. This tidal friction, as it's called, helps melt the interior of Enceladus and keep the water in this molten or partly molten state.
One mystery is how much water actually exists beneath the surface. Could the miniature moon be hiding an underground ocean?
We infer that there is a liquid ocean because there needs to be a source of water to power these geysers. The ocean may not extend under the entire globe of Enceladus. It may be just beneath these regions where the geysers are going off, but there has to be a significant reservoir of liquid water beneath the surface of Enceladus.
If liquid water exists beneath the surface, it could be teeming with organic molecules. These, along with relatively warm temperatures, are the essential ingredients for creating life.
It would be incredible if we were to find life, primitive life, underneath the surface of Enceladus. We don't expect complex creatures such as ourselves or rabbits or turtles, but even primitive bacterial or microbial life, independent of life on Earth, would be one of the greatest discoveries ever.
Enceladus actually orbits within another wonder of the solar system. Number 6, the rings of Saturn. The rings, named in alphabetical order as they were discovered, are among the most dazzling sights in the sky.
The Voyager spacecraft first visited Saturn quite a while ago. And now with the new images provided by Cassini, it's like putting on a pair of 3D glasses for the first time to be able to see with great detail what's inside Saturn's rings.
Among the 7 main rings, it's estimated that the gaseous planet has thousands of ringlets comprised of 35 trillion tons of ice and dust, containing roughly 26 million times the amount of water on Earth. Yet their origin has eluded scientists for centuries.
We really don't know their origin. They may consist of material that never had a chance to form into a moon because of gravitational influences of Saturn itself. Or maybe they're a moon that wandered too close to Saturn and got broken up, shattered by the tidal gravitational effects of Saturn. Or possibly even a comet came in too close to Saturn and got tidally disrupted by Saturn's immense gravitational field.
What's even more remarkable is that scientists have counted 62 moons embedded in Saturn's rings. New images indicate that these tiny satellites have taken the rings to new heights. August 11th, 2009. A rare equinox photo of Saturn shows her rings edge on to the sun. The image unveils a shocking fact. The bright bands that once appeared to be solid and flat actually contain ridges spanning from a few feet to mountain ranges taller than the Alps.
When you look at Saturn's rings from a telescope on Earth, they look completely smooth and featureless. But now we see that there are regions where the ring particles are piled up into what you could call mountains, which can be several miles high.
But how are these mile-high mountains formed? NASA's Cassini mission actually captured images of embedded moons sweeping through Saturn's rings, causing them to twist and ripple, creating ever-changing patterns. In Saturn's A ring, the outermost of the large bright rings, the moon Daphnis has carved a vertical peak, which is over 2.5 miles high.
The moons are interacting with Saturn's rings in such a way as to either pull material slightly above the ring or below the ring as the moon goes round, because its orbit doesn't quite match that of the ring itself.
The ring system surrounding Saturn is a spectacular sight. But on a neighboring planet, there's a very different scene, one almost too monstrous to believe. It's number 5 in our countdown of the 7 amazing wonders. A raging storm that's nearly 3 times the size of Earth. As we continue our countdown of the 7 wonders of our solar system, we leave behind number 7, Enceladus, and number 6, the rings of Saturn. We now blast off to number 5, Jupiter's Great Red Spot. This mother of all storms is about 3 times the size of Earth.
We don't know exactly how the red spot formed. It's been there as long as we've been looking, as far back as the 1650s. So it was there before we started really paying attention.
The Great Red Spot is actually an ancient storm that's been spinning wildly for centuries. The supersized vortex towers 5 miles above the planet's cloud tops and dwarfs any storm system on Earth.
The 400-mile-an-hour winds measured in Jupiter's Great Red Spot are faster than some of the most powerful winds measured in tornadoes here on Earth. Yet tornadoes on Earth only last maybe a few tens of minutes, or at most a couple of hours, whereas Jupiter's Great Red Spot's been going strong for at least 400 years, and it's 3 times the size of Earth. Now that's one storm you don't want to get caught in.
Most tropical storms in Earth's southern hemisphere spin clockwise as our planet rotates. But on Jupiter, the Great Red Spot follows an unearthly path.
The Great Red Spot, which is in Jupiter's southern hemisphere, rotates counterclockwise. It's anticyclonic. And that's because it's a high-pressure system, unlike the low-pressure systems here on Earth associated with storms. So when you have a high-pressure system, the airflow is naturally the opposite to that of a low-pressure system.
The origin of this long-lived storm has baffled astronomers. But now, science may be on the verge of unraveling its stormy secrets. The Hubble Space Telescope recently snapped images of 3 smaller storms on Jupiter called white spots. Within 3 years, the 3 white spots merged to form one Earth-sized storm. Then, the unexpected happened.
Over the course of only about a week, the storm turned from white to bright red. It's now known as Oval BA, or sometimes Red Junior. Why it turned red and exactly how that happened is still a mystery.
Astronomers now suspect a similar merger may have also created the Great Red Spot. And like Red Junior, the ferocious storm may have originally been white. But as its speed grew faster, it began dredging up material from deep in Jupiter's atmosphere. One of the compounds could actually be a form of sulfur.
We don't fully understand why the red spot has its characteristic brick red color, but probably there are chemical compounds which are reacting with the sunlight and are giving it this color.
Astronomers have been closely monitoring the Great Red Spot. And in the last decade, they have detected an astonishing change.
We've been watching the Great Red Spot shrink and actually become rounder for some time now. Who knows if it's going to persist for another 400 years or maybe disappear entirely.
The Great Red Spot is by far the biggest storm in our solar system. But after leaving Jupiter, we head about 200 million miles in the direction of the sun and have a close encounter with another barely believable wonder. Number 4, the asteroid belt. Scientists want to know more about the origin of this cosmic junkyard of wayward debris, which is left over from the formation of the solar system.
For a long time, we thought that maybe there had been a planet there that got pulverized and we were just seeing the debris of some major catastrophe. But we pretty much now realize that a planet never was able to form there. The gravitational pull from Jupiter and the other planets just made it impossible for material to coalesce into a planet.
We traverse through 100 million miles of rocks, some as small as several feet, others bigger than cities. The belt probably contains millions of rocky pieces. Yet if all the asteroids were condensed into one boulder, it would be smaller than our moon.
We can start to learn more about the history of our solar system by studying the small bodies in our solar system, the asteroids. We'd like to know how they moved around, how are they affected by the giant planets, and what is their ultimate fate? What will happen to them?
Popular movies have portrayed the asteroid belt as a cosmic obstacle course, a place where spaceships dodge enormous boulders that constantly collide and jostle for position before hurtling down from space to destroy planet Earth. But has Hollywood gotten it wrong? How congested is the asteroid belt? That's what one viewer wanted to ask the universe. So Joel T. from Kansas City, Missouri texted us. Have movies accurately represented what the asteroid belt actually looks like?
Thanks for the question, Joel. I know this is a bit shocking, but the asteroid belt hasn't always been portrayed terribly accurately in most blockbuster movies. If you were orbiting an asteroid inside our solar system's asteroid belt, you wouldn't be able to see big cratered surfaces of other asteroids flying right next to you. In fact, they probably look just like distant points of light. That's because the average separations between most asteroids in the asteroid belt are much larger than their actual sizes, so they really just look like dots.
In fact, an average distance between two asteroids can be 1 million miles. However, among this spacious sea of odd-shaped rocks exists a round ball. Ceres is the biggest asteroid in the solar system. The awesome 600-mile-wide rock contains a fourth of the entire mass of the asteroid belt.
Most asteroids in the asteroid belt are lumpy shaped, kind of like potatoes. But Ceres is different. It's actually big enough to have enough mass, to have enough gravity, to crush itself into a round shape.
Because of its spherical shape, Ceres was upgraded. Scientists recently listed it as a dwarf planet, the same designation given to Pluto.
The modern view of Ceres is that it's not big enough to be called a genuine planet, but it is big enough for it to have formed a roughly spherical shape, but not big enough to be a true planet.
This fourth wonder not only holds unique artifacts from the formation of our solar system, it also harbors potential weapons of mass destruction. Many asteroids have escaped the confines of the asteroid belt. And at any moment, one of these rogue space rocks could repeat history. And no one will live to talk about it. So far, our journey through the 7 wonders of the solar system has taken us to the geysers of Enceladus, the rings of Saturn, and the Great Red Spot on Jupiter. Now, we continue to travel through the fourth of our wonders, the asteroid belt. This band of leftover debris has even made it to the big screen. And the rocks Hollywood is obsessed with the most are those that escape the asteroid belt and head for planet Earth. Near-Earth objects, or NEOs, are cosmic rocks like asteroids or comets, which strike Earth almost every day.
We're really very interested in near-Earth objects, objects that pass across the orbit of the Earth around the Sun, because occasionally they can and do collide with the Earth. And if they're big enough, they can cause vast destruction here on Earth.
On April 14th, 2010, cameras caught sight of a 3-foot fiery asteroid streaming over the Midwestern United States. Fortunately, the cosmic rock broke into tiny pieces before hitting the ground. But in the past, large asteroid impacts have created gigantic craters and even triggered mass extinction events, like the Chicxulub asteroid that killed off the dinosaurs.
Over the last billions of years, Earth has been hit many times by asteroids of various sizes. The impact that occurred roughly 65 million years ago that perhaps wiped out the dinosaurs was an example of something that was about 6 miles across. It slammed into what is now Mexico and caused huge global ramifications for the Earth.
A number of new space surveys are currently tracking all near-Earth objects that are large enough to destroy a modern city, or even worse, ignite a global catastrophe.
We know of most of the objects that are larger than a mile that can intersect the Earth's orbit. And so the effort now is going into finding these sort of stadium-sized objects that, while not completely devastating to the entire Earth, would be a huge deal if they hit Earth.
As we leave behind the asteroid belt, we chart a course to the next of our 7 wonders, Number 3, Olympus Mons. the largest volcano in the solar system. As we approach the planet Mars, we immediately catch sight of this mammoth mountain.
The base of it is about almost 350 miles across. That's as though the base of the mountain were from Los Angeles to San Francisco. So even though it's so high, the slope is very gradual. You would barely know you were climbing a mountain. It's not like a steep volcano. It's just, it's a smooth, low slope, but it just goes on forever.
Olympus Mons is located in the Tharsis Bulge, a region on the red planet that's home to other massive volcanoes. If you climb the 13 miles to its summit, you could take in a view of the very edge of the Martian atmosphere.
Olympus Mons is several times higher than the highest mountains on Earth. And its base is hundreds of miles across. And it's been formed over the last billions of years by eruption after eruption after eruption, which has slowly surfaced it with successive layers of lava.
100 million years ago, hot lava rivers poured down from its peak to cover millions of square miles of the red planet. Today, Olympus Mons is 100 times the volume of Earth's largest volcano, Mauna Loa, located on the big island of Hawaii.
Olympus Mons got so much larger than anything here for, well, a number of reasons. One is certainly there was just a lot of volcanic activity. A second is that Mars's gravity is much lower. You weigh a lot less on Mars. So as the mountain built up, it didn't compact back down. It was able to build up to a pretty huge volcano without collapsing.
The third, and perhaps most important reason why Olympus Mons is so huge is that Mars doesn't have plate tectonics, the movement of crustal plates that rest on top of the molten interior of bodies, such as Earth.
Olympus Mons grew to such a big size because of the lack of tectonic motions on Mars. The hot spot from which the lava, the magma, emerged remained at one location, allowing more and more material to build up and create a super mountain, a super volcano.
Mars is now presumed to be geologically inactive. But is the volcanic beast really dead, or merely a sleeping giant? The European Space Agency's Mars Express mission recently captured the highest resolution images ever taken of the planet's lava flows. Some flows date back 115 million years, but others are only 2 million years old. And on geologic timescales, that's very recent, which suggests there still may be some volcanic activity.
If we look at the surface of Olympus Mons, we see especially that there are lava flows which have very few craters on them. And so we know that those lava flows are perhaps 10, 20 million years old at the oldest. But the eruptive activity has been going on until the relatively recent past, if not right up until the present day.
Olympus Mons may have once produced vast amounts of lava, but its hellish heat paled in comparison to the current temperatures of number 2 on our countdown of the 7 incredible wonders of our solar system. This may look like a ball of flames, but its surface is an ocean of 10,000-degree plasma with waves, winds, and massive eruptions as explosive as 1 billion tons of TNT. Our next wonder of the solar system has been Earth's best friend and foe. It's bathed our planet with heat and energy, but it's also blasted us with potentially deadly, highly energetic particles and waves. We now navigate around number 2, the sizzling surface of the sun.
The surface of the sun is really quite chaotic. It's always boiling and bubbling. In particular, there are hot cells of gas that come out from the interior up, radiate their energy, cool, and then come back down. So this convection, as it's called, this boiling motion, similar to what you see in a boiling pot of water, is occurring near the surface.
We have never been able to look at the sun's surface up close. Until now. NASA's STEREO, or Solar Terrestrial Relations Observatory, is a 2-year mission that provides a revolutionary look at the sun in 3D. Its 2 observatories record the flow of energy and matter from the sun to Earth.
The arrangement of STEREO is to have 2 spacecraft, one in Earth orbit somewhat ahead of the Earth and one in Earth orbit somewhat behind the Earth. So they're separated, like our eyes are separated, in order to help us give us 3D vision of what we see.
The 3-dimensional video makes you feel like you're an arm's distance away from touching the sun's visible surface. Called the photosphere, this is where solar storms and other violent phenomena occur.
The surface of the sun, if you were somehow able to go there and protect yourself, is an incredibly noisy, hot, and violent place. There are temperatures, thousands of degrees. There are continuous magnetic storms that create huge, basically thunder-like sounds.
This 3D movie focused on a prominence. This is a relatively cool, dense cloud of plasma that sits suspended above the solar surface, supported by magnetic forces. As seen here, prominences can occasionally rip free and jet into space.
Our sun has an incredibly powerful magnetic field. Those magnetic field lines can disconnect or break, releasing huge bursts of energy. And these throw up giant blasts of plasma that come out along curious-looking arcs, but these are actually following the magnetic field lines around the sun.
Eruptive prominences can occur in tandem with another solar ejection that can deliver a double punch if directed at the Earth. NASA's Solar and Heliospheric Observatory, or SOHO, recently took dramatic movies of coronal mass ejections, or CMEs. These massive bubbles of hot ionized gas contain up to 10 billion tons of solar material. They shoot out into space at speeds of several million miles an hour.
Coronal mass ejections are incredibly powerful storms. They can be as massive as 1 billion H-bombs, just huge amounts of energy. And sometimes those big blobs of plasma strike the Earth and lead to beautiful northern lights, aurora displays. They can also be very harmful to the Earth.
When large coronal mass ejections are blasted toward Earth, they can trigger geomagnetic storms. These blobs of ionized particles can damage or even terminate satellites, as well as fry our electrical grids. What's more, they're extremely hazardous to astronauts when outside of the protection of a spacecraft.
The CMEs generate X-rays. So if you're out in space, you would get quite a dose of radiation if you were in one of these CMEs. Luckily, our atmosphere absorbs most of the X-rays, and we don't experience the bad effects here on the surface of the Earth.
These latest images are chilling reminders that our sun's surface is a force to reckon with. And things may really heat up on our home star in the very near future. Solar activity runs through an 11-year cycle. In 2013, our sun will be at the peak of this cycle, called the solar maximum. At this time, the surface of the sun could create the perfect storm.
The sun has had in the past big solar storms that have knocked out power grids and our communication satellites. There will be more storms. They might happen at any time, or they may not happen, you know, in our lifetime or even in the next millennium. We just don't know.
But one thing a solar storm can't destroy is number 1 on our countdown of the 7 wonders of our solar system. It's the 5th largest planet. 1/10 of its surface is permanently covered with ice, and its hot interior has been churning up enough magma to keep volcanoes erupting for billions of years. The exploration of our cosmic neighborhood in 3D climaxes with a touchdown on number 1 of the 7 wonders, Earth.
The Earth, without a doubt, is the single greatest wonder in the solar system. The Earth is so perfect for our existence. There's liquid water, there's an atmosphere, there's comfortable temperatures. It's just a great place.
Earth, the 3rd planet from the sun, is brimming with breathtaking beauty. Unlike any other body in the solar system, liquid water covers nearly 2/3 of its surface. Its continents inherited a diverse landscape, and it's the only planet confirmed to support life in all its amazing forms.
Earth has a number of different features that make it truly unique in our solar system. For one thing, it's not boiling hot, and nor is it freezing cold. It's just at the right distance from the sun to be a very moderate temperature that supports life. For another thing, it's not completely a water world, nor is it completely a dry desert either. It's got just the right mix of land and ocean to support a wide variety of species.
Science is now getting closer to solving the mystery of how life got started by retracing the steps of our planet's formation. $4.6 billion years ago, in the swirling disk of debris left over from the formation of our newborn sun, gas and dust particles began to clump together. They eventually formed large boulders made of rock and ice that we see today as asteroids and comets. For millions of years, these bodies collided and coalesced to form planets. During this birthing process, Earth acquired some special properties. One unique feature on Earth is abundant liquid water. It is thought that the earliest volcanoes spewed out massive amounts of steam, which condensed into rain and supplied the planet with water. But recently, new sources of water have been suggested.
Some of the water might have come from comets, or some of the water might have come from an outer belt of asteroids that was rich in water. In other words, some of the water could have come from the rocks that made the Earth near the end of this era of heavy bombardment.
And water appears to be a key component for the origin of life. It was previously theorized that life began in a primordial soup, a warm pond containing energy and atmospheric elements to make amino acids. However, the most recent pioneering research makes a strong claim that the Earth's own chemical energy and rich proteins seeped up through hydrothermal vents deep under the ocean. Over time, this mixture jump-started life by producing living cells.
We know that liquid water is essential to life, and life probably got started in a water environment. Whether it's in the deep ocean at the volcanic vents or in a shallow pond, we don't really know where and how precisely life got started here, but it did, and it's the only planet that we know where life actually exists.
Regardless of how life started, a fortunate event made it possible for complex creatures to evolve. About 3 billion years ago, ancient underwater bacteria began to use water, carbon dioxide, and the sun's energy to produce carbohydrates in order to survive. This process, called photosynthesis, injected vast amounts of oxygen into seawater and eventually our atmosphere.
A huge step happened in evolution when the Earth got polluted with oxygen. We didn't start with a rich oxygen atmosphere, but later the oxygen atmosphere that developed on Earth, basically from photosynthesis, allowed life to get a lot more complex.
After a few billion years of planetary and biological evolution, the first plants and animals emerged from water onto land. It's estimated that modern humans came onto the scene a mere 200,000 years ago. And with our evolution came the technological revolution of the planet. From ancient man-made monuments to bustling metropolitan cities, human beings changed the way Earth looks on the ground and from space.
The Earth's surface has started to be modified very significantly by cities, by human activity. We're part of the Earth. We've created all these changes on its surface. So the Earth's geology, in some deep sense, has been radically altered by the appearances of cities, by the appearances of all the things that we do on the surface. And that's something that's remarkable and which, as far as we know, is not happening anywhere else. Certainly it's not happening anywhere else in our own solar system.
Our 3D cosmic tour has taken us to 7 wondrous sights. The icy, geyser-laden moon Enceladus, Saturn's sensational rings, Jupiter's great red spot, the largest volcano, Olympus Mons, the mysterious asteroid belt, and our stormy sun. But this unforgettable adventure would not have been possible without our home planet, Earth, a place with endless possibilities. Over the last century, humans have manufactured metals and other materials from our planet's crust to build spacecraft. Our technology will enable us to blast off, to explore the other wonders. We'll be able to marvel at these distant domains and realize that we're part of a much wider cosmic world. These awe-inspiring phenomena allow us to ponder who we are and why we're here in this magnificent place we call the universe.